Good afternoon, everyone. My name is Jenny Ramirez from PNRI, and I am here with you today to share to you our major results for our project entitled Extraction of Radionuclides, Rare Earths, and Other Valuable Industrial Elements from Philippine Phosphogypsum Tailings. This is the conventional processing of phosphate fertilizers from phosphate rocks, which are being imported from more than 10 countries since 1980s. This phosphate rocks is known to contain significant concentrations of uranium, radium, REE, and several industrial elements. During wet acid processing with sulfuric acid, two byproducts are formed, phosphoric acid and phosphogypsum, which is a residue or a waste byproduct. Here, 80% uranium goes to phosphoric acid, while 60 to 80% radium and REE precipitates with phosphogypsum. Other elements goes to both byproducts. We have estimated about 10 billion metric tons of accumulated PG, and the lack of sustainable processing and the recycling options for this residue could result to successive accumulation, which may cause negative impacts to human health and the environment. In this project, we see phosphogypsum as an underestimated secondary resource of critical elements, which are not being recovered and are therefore lost forever from our economy. So the main objectives of this project is to conduct research and exploration to characterize our PG tailings, to select an applicable method for REE recovery, and to assess its radiation risks and resource opportunities. The next steps of this study would be to develop REE technology, leading to its demonstration in a commercial scale. This is actually a spin-off from our UXP project, or the uranium extraction from phosphoric acid, and this was officially started in 2018, and in the same year we had an IAEA expert mission on potential utilization and management of phosphate resources up to its scaled-up developments. In the same year until 2019, we did our fieldworks. We had in-situ radiometric survey at 270 point location in these 8 PG ponds, and characterization of 120 surface PG samples and pit samples. And in 2020 to 21, we did our preliminary REE recovery or acid leaching. We had 2 publications from this study, and let me share to you in the next slides our main results. The high standard deviation and the range of activity concentrations of KUTH radio elements indicate varying radioactive characteristics in each pond that is attributed to the processing of more than 10 types of phosphate rocks. We can also see here that the mean activity concentrations of potassium and thorium are within permissible limits, while the concentration of uranium is around 19 times the world average. All mean values of these radiological risk indices exceed the recommendable safe limits, and the practical way to mitigate this is just a simple dilution of PG residue with non-radioactive materials to lower the radiological risks to reasonable level. Shown in these figures are the RE concentrations in 2-meter trenches in these 24-point locations. Figure D shows us that RE concentrations range from 187 to 375 ppm, but it could go as high as 6,000 ppm. Evident in Figure C is the cerium depletion and yttrium enrichment found in Pond 2-3. And also here in Figure D are the major rare earths that is dominated by yttrium, followed by cerium, lanthanum, then neodymium. With the 10 million tons of PG, there's an estimated of 2,600 tons of rare earth oxides that amounts to $80 million. And assuming 50% recovery, our ongoing fertilizer production could supply 7 to 10% of the country's demand. We can see from these historic pilot scale experiments that REE recovery from PG is not a new idea, and up to this date, there is no commercial operation due to its technical and economic challenges. But given the economic importance of rare earths and the uncertainty of its future supply, we urge to go one step further and accept its techno-economic challenges and implement research and policy measures that encourage public-private partnerships with the goal of developing commercial methods to recover and use, rather than loose rare earths associated with PG here in the Philippines. That ends my presentation. Maraming salamat po.